Hey boys and girls, so today we're going to be going over Unit 6, Lesson 5, which is Applications of Systems of Linear Inequalities. Before we get started, just make sure that you write your name at the top of the page, and let's begin. So as we look at the do now, it says which words represent the following inequalities, and then we want to use the word bank below to help fill in our table. So I already went ahead and filled in our keywords, so while you guys are filling them in, I'm just going to explain each one. So this I know would be the less than symbol. So when I look at the keywords in my word box, that's the only word that I would want to fill in is the less than keyword. All right, this is the greater than symbol. So again, I'm going to include the greater than keyword. I also want to include exceeds, because if I'm exceeding something, that means I want to be beyond it. So I don't want to equal it. All right, like these guys down below, I just want to be beyond. I want to exceed. So again, that would just be a greater than symbol keyword. As I look at the less than or equal to symbol, if it says maximum, like the maximum grade you can get in this class is 100, that means you can get 100, it can equal 100, but that's the maximum. I could go less, I could be less than as well. All right, same thing with at most. The most you can pay to get in the, in a cab, is $20. So again, the most I can pay 20, but that would be it. If anything, I'd have to be less than that 20 bucks. All right, and then no more than and does not exceed would go in that category as well. And then last but not least, we have the greater than or equal to symbol. Again, I can equal the number or I could be greater than. All right, so as we look here, we have at least. So if it says that the least amount of money you can get a sandwich from TJ's would be $10, that's the least amount of money you're gonna pay to get a sandwich. So I can pay $10, but I can't pay any less. If anything, I'd have to pay more. So again, that would be the greater than or equal to symbol. Same thing with minimum and no less than. Those key words would also represent the greater than or equal to symbol. All right, if I said that the minimum grade you need in this class is a 65, that's the minimum. So that can be your grade, it can be a 65, but that's the minimum. I can't go any lower. If anything, I'd have to go bigger. All right, so greater than or equal to. All right, we're gonna use these keywords in our lesson today to help as we look through these word problems. So I'm gonna just scroll down here to example 1 and let's read it together. It says, an electronics store sells DVD players and cordless telephones. The store makes a profit of $75 on the sale of each DVD player. D is going to represent DVD players. And a $30 profit on the sale of each cordless phone. And cordless phones is going to be represented by the variable P. The store wants to make a total profit of at least $255 from its sales of DVD players and cordless phones. Which inequality represents this situation? Anytime we have a word problem, we've been going over cubing it, circling those key numbers, underlining the question, boxing our math action words, so then we can kind of see what we have after we're done. So I'm going to go back and I'm going to do that as I read this question. All right, so the first sentence, an electronics store sells DVD players and cordless telephones. All right, I'm going to keep going. The store makes a $75 profit, I'm going to circle that, a $75 profit on the sale of each. Each is a key word here, that's a multiplication word, so I'm going to use parentheses to represent that. So $75 is going to be the profit on the sale of each DVD player. All right, and then again, DVD players is being represented by the variable D. D would be a number here because how many DVD players did they sell? I don't know. All right, so I circle my key numbers, box my action words, that's a multiplication word. Now if I continue reading in a different color, because this is a different item, all right, $30 would be the profit for the sale of each. Again, each is a multiplication word. On the sale of each cordless phone. All right, again, P represents cordless phones. P would be a key number here because I don't know how many cordless phones were sold, but I know what's the number, I'm going to circle it. The store wants to make a total profit of at least $255. Well, at least is a key word. We just went over it in the do now. At least represents the greater than or equal to symbol. So I'm gonna write that below. All right, at least $255. Again, that's a key number, so I'm gonna circle it. And it says from its sales of DVD players and cordless phones. Which inequality represents this situation? This is the question, so I'm gonna just underline that here. So as I look back at my answer choices, because it's multiple choice, which is really helpful, before I look at the word problem, I wanna just check 75D, 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 75D. All right, so it looks like all of these guys are the same. They all have a plus, and they all have a 30C. But that makes sense because it was $75 times D, and that's what I have, 75 times D all the way through. $30 times P, again, 30 times, oh, here this should have been the letter P, all right, all the way through. And then we have at least $255. And again, I see that 255 at the end. So the only thing that's different here is the inequalities that are right down the middle. So I'm gonna highlight those out here. I need to decide which inequality is gonna represent this word problem that we're reading over here. And as I look through, we know that at least represents the greater than or equal to function. So as I look back, I can see greater than or equal to is being represented down here in choice 4. So that's gonna be my answer. And then it says on the side I have to explain my answer choice. So I'm just gonna write out that at least, all right, those key words here, at least represent greater than or equal to. Write this with me. That's how I know this is the symbol that I wanted to look for when I see those keywords, all right? Because if I want at least, the least amount of money that I want to make is $255. So I can make $255, but that's the least. If anything, I'd have to make more. So that's why I'm getting the greater than or equal to symbol. All right, let's jump on to the next page. All right, here's example 2. David has 2 jobs. He earns $8 per hour babysitting his neighbor's children, and he earns $11 per hour working at the coffee shop. Write an inequality to represent the number of hours, which would be X, for babysitting, and the number of hours, which would be Y, working at the coffee shop. All right, that David's gonna need to work to earn a minimum of $200. So again, I'm just gonna follow through with the same steps we did on the first page. I wanna cube this question. Here we go. David has 2 jobs. He earns $8 per hour. 8 is a key number. I'm circling it. Per is a multiplication word, so I'm going to put parentheses. And again, it's $8 per hour, but I'm going to leave this alone because I remember in the question, it tells me I want to use X and Y when I'm talking about the hours for the babysitting and the coffee shop. So I'll come back to that. All right. So it's $8 per hour babysitting, all right? And then he's gonna earn $11. I'm gonna use a different color because this is a different job. He earns $11 per hour. Again, per is a key word. It means multiply. I'm gonna use parentheses. And then again, hours is a key number, but I don't wanna use H. I'm gonna use X or Y, okay? And we'll get there in a minute. All right, so this is $11 per hour working at the coffee shop. Here's the question, I'm gonna underline it. Write an inequality that's gonna represent the number of hours, X, okay? Hours is X, that's a key number, so I'm gonna circle it. X represents babysitting. So now I know if he makes $8 per hour babysitting, it's gonna be 8 times X, because X represents the number of hours for babysitting, all right? And then it says the hours of working at the coffee shop is gonna be Y. So again, Y is a key number. Y represents the coffee shop. So again, this is gonna be 11 per hour. So this would be $11 times Y. Let me put a little Y on the side here. So 11 times Y, all right? That he's gonna work if he wants to earn a minimum, all right? Minimum is a key word. Let me box this. A minimum of $200. All right, when we see that keyword minimum, you could look back on the first page and check that table that we had filled out for what the inequality is gonna be. But just think about it. If I told you that the minimum he can make is $200, Or he won't have enough money for, a new phone. Here we go. Minimum, that is the lowest amount of money that he can take home. So he can make $200. It can be equal to 200, but that's the minimum. He can't go any lower, so that means he can only go bigger. That's going to be the greater than symbol. All right, so minimum is the greater than or equal to symbol, so he wants to be greater than or equal to that number $200. All right, so again, I want to write an inequality that's going to represent the number of hours X, all right, and the number of hours Y. Here we go. Let me grab my pencil here. So we're going to do 8 times X, which is really just 8X. All right, he also earns $11 per hour at the coffee shop. So that's going to be 11 times Y, 11 times Y. And we know that this whole thing has to be greater than or equal to $200. Now, the only thing that's missing is going to be the operation in the middle. So think about it. If he's going to try to accumulate $200 because he's saving that money, that's going to be adding all the money he makes babysitting with all the money he makes at the coffee shop, because again, he wants to have a minimum of $200. All right, so now that I've wrote down the inequality, I'm going to look at the second part. It says David worked 15 hours at the coffee shop. Use the inequality to find the number of full hours he must babysit to reach his goal of $200. So again, I'm going to go back and I'm just going to cube this thing. So it says here that he worked 15 hours at the coffee shop. Just because I have 2 different color pens, I'm using pink to represent the coffee shop. All right, so again, the coffee shop is being represented in pink. So if he has 15 hours have been worked at the coffee shop, that means I'm going to replace that variable Y with 15. Because if you look back at our word problem, we know that hours for the coffee shop is represented by Y, and I know that he worked 15 hours. So I'm going to rewrite this inequality, 8X plus, now instead of writing 11Y, I'm going to write 11 times 15. This is called substituting in. I am replacing my variable Y with the number 15 because that is the amount of hours he had worked at the coffee shop. All right, and this whole thing needs to be greater than or equal to 200. And now I'm just going to solve this like we would any other inequality. So I'm going to drop my line and solve here. Let's get this going. So we have 8X plus 11 times 15 is 165. And then on the right-hand side, I have that $200. I like to ignore the inequality until my last step. So I'm going to just leave this alone for right now. All right, as I continue solving, I want to move that 165 to the opposite side. All right, since I'm going to the opposite side, I'm using the opposite operation. That's the inverse. All right, so the inverse of addition is subtraction. So now all I have left is 8X on the left, 35 on the right. Last but not least, I need to divide both sides by 8. Again, the inverse of multiplying is dividing. So I'm going to divide 8 on both sides. That cancels. So I have X on the left. 35 divided by 8 is going to be 4.3. I did not divide by a negative, so my inequality is not going to flip. It's going to stay greater than or equal to. All right. So as I look back at the question here, let's underline that. It says use the inequality to find the number of full hours he must work if he wants this inequality to be true. Well, working 0.3 of an hour would not be full hours. Full hours would be integers like 1, 2, 3, 4, 5, right? Numbers like that. So I have to look at my inequality now to decide what my final answer would be. Since I can't equal 4.3 because that doesn't make sense if I'm answering the question correctly, that means I want to be greater than 4.3. So what's the next integer, that next whole number that comes after 4.3? It would be 5. So how many full hours does he have to work? 5 full hours. All right, and that would be our answer to number 2. All right, don't get too excited, boys and girls, but number 3 actually cannot be solved. We're going to give that baby a nice big X. Let's flip and go to example. All right, boys and girls, so I got a head start on example 4 just to save us a little bit of time. So I already read through the question and I cubed it, all right? But let's go over it together. It says, Edith babysits for X hours a week after school at a job that pays $4 an hour. So again, X hours, I know that's a number, so I'm gonna circle it. $4 an hour, that's saying 4 times. But for hours, they just told me that when she babysits, that's gonna be represented by X hours. So that's why I'm putting an X instead of an H for hours here. All right, so this would be 4 times X for babysitting. She accepted a job that pays $8 an hour as a library assistant, working Y hours a week. So this is very similar. So again, $8 is a key number. $8 an hour would be 8 times, but this one I'm going to use the variable Y because I know Y hours represents the amount of time that she works as a library assistant. She's going to work both jobs. She's able to work no more than 15 hours a week. No more than was a key inequality word that we had gone over on the first page. All right, when you see no more than, that's going to be the key symbol for less than or equal to. All right, because I can't work more than 15 hours, but I could work less than 15. All right, so I'm going to write it on the side here, less than or equal to, and that's going to be the key word, the key symbol for no more than. All right, and then it says due to school commitments. Edith wants to earn at least $80 a week. Again, at least is a key word that represents an inequality as well. At least $80 is the least. It is the least amount of money that she can make, but she can't go any lower. She can only go higher. So that's going to be the greater than or equal to symbol. All right. So again, she wants to make at least $80 a week working both jobs. The first part says write a system of inequalities. When you see this key word here, system of inequalities, that means I'm going to have 2. So let's write that on the side here. I'm going to have 2 inequalities. All right, and then after I write them, it says that I want to graph them, okay, on the set of axes below, which would be right here. So the first thing that I want to do is look at those key numbers that I circled. Notice how 4 represents a dollar amount, 8 represents a dollar amount, and 80 represents a dollar amount. I want to put all 3 of those numbers in the same inequality because they all represent money. So here I go. I'm going to say I have my amount of money that I make for babysitting. All right. I have the amount of money that I make at the library as an assistant. And then we have the total amount of money, all right, that she wants to make at the end of the day here. All right, so here we go, boom, boom, boom. For babysitting, babysitting is in purple. We said that's gonna be 4 times X, so that's gonna just be 4X. The amount of money at the library, we said the library was pink here, library, so that's gonna be 8 times Y. We wrote it up top. That's gonna be 8Y. And then the total amount of money that she can make has to be at least $80 a week. At least is the greater than or equal to symbol, so at least $80 for the week. And again, we're getting all of this with a combination of both jobs, so I'm going to add those puppies together. All right, let's look at the bottom here. Now that I'm done with 4, 8, and 80, I can actually just give those across so I don't confuse myself because I've already used the 4, the 8, and the 80, so I am done with those numbers. So the only thing that I have left is that 15, and 15 represents hours. All right, so now I want to think, how many hours a week does she work? Well, she wants to work no more than 15 hours. We said that's going to be less than or equal to 15. So instead of talking about the money she makes babysitting and at the library, now I want to talk about the amount of hours she works babysitting and at the library. So this is babysitting hours. This would be library hours. All right, and then this would be her total hours. All right, so again, we said the total hours is right here. It's 15 hours, but it's going to be less than or equal to 15. Now I have to figure out the babysitting and the library hours. If I look back, well, babysitting is represented by X hours. I want babysitting hours. That would just be the variable X. Library hours. I can see here that the library assistant represents Y hours. So again, this would be the variable Y. And again, I want to add all those hours together because I don't want to work more than 15. All right, no more than 15 hours can be worked. So these are the two linear inequalities that I would want to graph on this set of axes to the side. But something that's a little funky about both of them is I need to isolate Y. That means I want Y by itself. And right now, Y is hanging out with the number 8. It's also got a 4x hanging out on the left-hand side here, all right, for my money inequality. And the same thing for the hours, all right? Y is hanging out with that variable x, all right? And I need to get Y all on its own. So I'm gonna pause the video. I want you guys to solve for Y. I'm gonna do it as well. Make sure you guys are getting to your next class on time here. All right, so I'm gonna solve for Y, you solve for Y, and then we're gonna come back together to go over it as a All right, you guys, just to save some time here, I know that I worked out most of the question already, but I'm gonna go through the steps with you here. So I just rewrote that inequality that we came up with for the money situation, all right, down below. The first thing that I did was subtracted 4x to the opposite side, all right? These would have canceled out. Now I have an 8y, 80 minus, there we go again. All right, so we got an 8y, an 80, and a minus 4x. Again, I want to get y by itself, and he's still hanging out with that number 8. So the opposite of multiplying is dividing. I have to divide 8 on every single number here. All right, so when I divide out the 8, all I'm left with is y. 80 divided by 8 is 10. 4 divided by 8. Now, when you type it in your graphing calculator, it could say the decimal as 0.5, or it could give you a fraction 1/2. Both of these are correct, but you only need one. All right, and again, it was minus in between, so I'm gonna keep that minus in between as well. So that's gonna be the inequality I wanna graph that represents my money situation. Now, if I look at the blue, which was the hours, I just had to move that x over and I was done. So again, the opposite of a positive x is a negative x. So when I subtracted x to the opposite side, all I was left with was y is less than or equal to 15 minus x, and I was done. And then I grabbed these guys and I typed them into my graphing calculator so that I could look at the points that I wanted to plot. All right, so I plotted those points, I connected them with a ruler, went back, typed in the other inequality, again, connected those points with a ruler, all right? And then as I look at the question, it says determine and state, let me push this up just a smidge here, determine and state one combination, just one combination of hours that will allow Edith to do both things, to work at least 15 hours, all right, but also she wants to make that $80 a week. So I can see that my inequalities cross right here at that point. That's gonna be my solution. But it's gonna be hard to answer the question without labeling your axes, all right? So this part was a little bit tough as well. If you look back at the question, they had told us up top that X hours is represented by babysitting. So I know down below my X axis, I wanna let that be represented by babysitting. All right, again, in the question, they told me that Y hours represents the library assistant. So in my y-axis, I let that be represented by the library assistant job. So then when I answered the question, I knew that this coordinate point, which is really 10, 5, let me add that to my graph here, it's 10, 5, the x was 10, the y was 5. I know that 10, that x value represents 10 hours babysitting, and then my y value of 5 really represents 5 hours at the library. All right, this was a pretty heavy question. This was a Regents question. All right, make sure that you guys go back. If you need to pause the video or rewatch any section, you get that done, because I know this was kind of heavy to go through. Make sure at the bottom you get the closure done on your own.